Okay, so now we're going to do the last one on your notes, is number 4. The problem is y equals 1 over x minus 2. So what I'm going to do here is I want you guys to notice that that is the same thing as 1 over x minus 2 plus 0. So we can see what our horizontal and vertical asymptotes are. We know that that term that I just wrote, the plus 0, tells me what my horizontal asymptote is. And that is at the line y equals 0, which is this axis right here. It's running horizontally. Okay, x minus 2, this bottom part, if I set it equal to 0, I get the equation x equals 2. And that's actually the line of my vertical asymptote, running right down through x equals 2. Okay, now all I'm going to do is the same thing that we did before, is just go ahead and graph the parent function. I'm going to move 1 unit over here and 1 unit here, and I'm going to just graph those branches of the hyperbola right through that point where it's almost touching the asymptotes, approaching them, and right through there. Okay, and that's the graph. This one down here probably could have been a little bit better. Let me try to draw it a little better for you. It's right through that point. Okay? So that's the graph of this equation right here. Very simple. But let's talk about some other things about it. So what are our shifts? Well, we know that we had to move over. This guy tells us our horizontal shift. So we moved to the right 2. So let me just write that down. Right 2. And up here we can see that, we only had a plus 0 there, so there was no vertical shifts. What are our asymptotes? Well, our horizontal asymptote is just this line right here that I dotted in red right here. I'm just kind of redotting it. That's my horizontal asymptote, and that's the line y equals 0. Y equals 0, and that's our horizontal asymptote. So what's our vertical asymptote? What's the asymptote that is standing vertically? That is this asymptote right here, and that's the line x equals 2. My vertical asymptote. What's my y-intercept and my x-intercept? Okay, so the y-intercept, right, that is when we intercept the y-axis. So our function's going along, and it hits the y-axis. Does that ever happen here? Yes, it does, and it happens right here. So we want to find out what that point is, okay? So let's talk about that. How do we find out what that point is? Well, when it actually goes through the y-axis, what is our x value? Our x value is just 0, okay? So we set x equal to 0 in our equation to find out what our y value is. And so our intercept will be a point. So we have the equation here, y equals 1 over x minus 2. We know that our x value is going to be 0, and our y value will be something, but we need to find out what that something is. So let's plug 0 in for x. So we have y equals 1 over 0 minus 2, which is just negative 2. So that means that our y value is just negative 1/2. So this right here is my y-intercept. What about my x-intercept? How would we find the x-intercept? Well, let's talk about that. The x-intercept means that it's intersecting the x-axis, so somehow it crosses the x-axis. If we wanted to find that out, we would say, okay, when something's crossing the x-axis, we don't know where it's crossing, but we know that the y value is going to be 0. So we would say, we would plug in 0 for y in our equation. However, if we look at this graph, we can see that our x-axis is actually the asymptote. And we know that we can never touch the asymptotes right here. So it can never be the case that our function intercepts the y-axis. So there is no, let me write this, no x-intercept. Okay, what's my domain? Okay, so keep going down here, domain. What is that? So domain is everything that if I look along the x-axis, if I look along this x-axis here, right, where will I see a function? Where will I see the function? Is it going to be everywhere that my x-axis sees a function? Let's try it. There's a little bit too much writing going on, so I'm going to erase all that stuff. Okay, where will I see the function? Look at your x-axis. Well, I see the function all along this part of the x-axis, but right when I hit here at this value of x, I don't see function up here, and I don't see function down here because that's an asymptote. So it looks like my domain is all the possible numbers except when I hit this part of my x-axis, okay? So what is that point? Well, that point is at 2. So my domain is going to be all numbers except for 2. So we know all numbers we can express as negative infinity to positive infinity, right? But since we're not including 2, we'd say, okay, we're going to say negative infinity all the way up to 2, but not including 2, because if we were, we would have a square bracket, in union with everything except 2 off to infinity. Okay? Now, what is the range? Okay, so let's talk about the range. If I look at my y-axis, if I'm looking here at my y-axis, where on the y-axis do I meet the function? If I draw lines through the y-axis, well, I see it there. I see him there. I see him there. I'm going to go up. I see him there. If I'm right here, I don't see the function. If I'm right at 0. But if I'm above 0, I eventually meet the function, right? So at that asymptote right here, I don't see the function anywhere. I could draw the line going as far as I wanted, but I would never see that function. So it looks like this range, the range of this function, is all y values except for the y value right here, and that's at 0. So we'll express the range similar that we express the domain, and we'll say, okay, all y values, so everything negative, all the way up until I hit 0, but not including 0, in union with 0 all the way off into infinity. Okay, so that's all numbers except for 0. So all y values that do not equal 0. That's another way to express it, just as the domain is all x values that do not equal 2. Intervals of increase, let's look here. Is it increasing? Let's see. Well, when I look at that function, that blue guy, if I were to walk along the function, will I be falling down? Will I be sliding down? It looks like I definitely will be over here. I'll be sliding down. And then if I walk along him over here, I'll be sliding down for sure. So it's never going to be increasing because there's never a time that it will be increasing if I walk on that function. Now, when I walk on the function, I'm always walking from left to right because I'm going in the direction of my number line. These numbers are negative, and these numbers are positive. Start from left to right always, then you'll get the answer. So no, it is never increasing. So my interval of increase, none. What's my interval of decrease? Let's see. Is the function decreasing everywhere that it exists? Our interval, remember, we're always talking about intervals in relation to the x-axis, okay? So, over here, it feels to me like I'm decreasing everywhere that the function is defined, and even up here, everywhere he's defined, he's decreasing. So where is he defined on x? Well, he's defined on x exactly where the domain is. Everywhere that the function exists on x is where it's decreasing. And we said that our domain, let's see, where did we say our domain was? We said our domain was right here. Okay? So the interval of decrease is the same as the domain in this case, negative infinity to 2 in union with 2 to infinity. That's because, if I'm at negative infinity, I'm still decreasing. If I'm all the way out there, I'm still decreasing all the way up until I get to 2, because once I get to 2, which is this asymptote here, this vertical asymptote, nothing happens because the function's not defined. But then after 2, it's decreasing again off into infinity. Okay, now end behavior. What's happening as x approaches negative infinity? What's happening there? So as I go this way, this is the direction of negative infinity. What's happening to the y values? Well, x is going further and further out here, but where's y going? It cannot go past the asymptote, and the asymptote is located at 0. So y is approaching the asymptote. The y values approach the asymptote, which is 0. So we'll say that the end behavior is as x approaches negative infinity, y, or we call it f of x, same thing, that approaches 0. Now what happens as x approaches positive infinity? Let's see. What's happening over there? Well, on our graph, as I move this way in the positive infinity direction, it looks like it's just decreasing. The y values are moving slower and slower up to 0, because they're going to hit that floor. The asymptote, in this case, for this guy, this blue guy, it's the ceiling, but for this blue guy, it's the floor. So the asymptotes are approaching that floor, which is 0, y equals 0. So as x approaches infinity, my y value, or f of x, this, y approaches 0 as well. And that's it.